In my project with two of Germany's largest banks, the Sparkasse and Volksbank, I've been working on a data warehouse project. And actually, they did quite well already because they were using Hadoop as big data distributed storage system, which is, as you might know, different from traditional databases like Oracle SQL or Microsoft SQL, because they are not meant to store a lot of data, and especially not for analytical workloads where you're calculating over different columns, like how much revenue did we generate in region X and Y. And usually this tends to be really slow with SQL databases. And this is why you would use something like Hadoop to increase this analytical processing engine. Also, a nice thing is of a distributed system like Hadoop or the latest system we implemented, that it's not running on one huge vertical server, meaning you don't need these expensive machines with 200 gigabytes of RAMs, but instead you take a lot of smaller consumer grade servers that are all linked together, and just the workload is distributed to all these tiny little cheap servers. And something they were facing is that Hadoop actually increased their support prices a lot in the recent times, a little bit similar like to what you might know of VMware's VM solution and so on. But the thing is, they wanted to switch to an open source system. And actually what we did is using Kubernetes, or in their case for managed Kubernetes OpenShift, as a basis, to use Trino as a distributed storage engine, and the data being saved as Parquet files in different S3 buckets. As you might know from AWS S3, it's an object storage. And the smart thing is objects are really easy to replicate over different servers, meaning we have 3 copies of data in 3 different servers, but all randomly mixed, that we can basically prevent one server burning down, causing a huge data loss, but instead we kind of split up the data through our distributed systems. Therefore, we are prone, or we are safe from data loss accidents. And like I said, we can do the calculations not on one server, but on many servers simultaneously. And as you might know, SQL is not really meant for a large amount of data, but an object storage is. And using tools like, for example, MinIO, we can replicate this AWS S3 experience and have a distributed storage system with the Trino querying engine on top, meaning we can not only connect the S3 buckets for big data, but we can also collect traditional old databases in there. It's kind of like an aggregator for different SQL queries. And the nice thing in the end is we will have one backend to connect to all our different data sources, which can be anything. Like it could even be, I don't know, even emails saved into a bucket, PDF files, images, and so on. And we can actually query information from all these different databases via this Trino connection. And that is what I did in this project with the Sparkasse and Volksbank. And it actually is used a lot nowadays, especially for analyzing bank account statements, for transactions, like detecting, for example, errors in transactions, prevent credit card fraud, and so on. And this can all be done with one system, which is a huge game changer, especially in large enterprises where you're usually having like millions of different data sources. No one knows what's happening. And especially for that, a data catalog comes in play, which is kind of a registry of like your Trino database, but not only with technical links like the API calls required to connect to them, but also with meta information about the company. Like you can tag different storage or different tables as, for example, marketing data or department data. Let's say you have a specialized department in plants, and you can tag different data sources as plant-based You can add descriptions, you can kind of have an interactive documentation about your data. And using RBAC, role-based access control, together with this kind of data catalog and data warehouse, you can even trim permissions down to the minimum, meaning your plant department will only be able to access plant data sources. And you can even add tiny little additions like, I don't know, the plant department can only see pseudonymized or anonymized versions of these tables, which is all done on the fly by, for example, this Trino engine. And this opens a huge range of possibilities, meaning, for example, if you're working with sensitive data like a clinic I've been working with, you can only limit access to the real, true source data, for example, to the research department, and publish your data basically for everyone in an anonymized way. Meaning, for example, marketing can see all the data, but just anonymized, which is done on the fly automatically, and your research department will be able to see everything. And that comes down to what a good data warehouse is. Like I said, it's an aggregation of different data sources. It's using high-tech tools to, for example, save license costs, I don't know, and do not use these huge Oracle servers that are expensive, and to kind of act like a data catalog that everyone knows what data do we have and what can we do. And yeah, if you're interested about something similar like that, you can either look around on my blog, because I have a lot of tutorial articles, or you can book a 1-hour consultation session, and that one, yeah, you can basically find everywhere on the website. Okay, I wish you good luck and see you soon.